Right now, somewhere in the dark expanse of our Milky Way galaxy, a star is dying in the most spectacular, violent way imaginable. It is not a quiet, gradual fade, like our sun will experience billions of years from now. This star is ripping itself apart, blasting its outer layers into space at thousands of kilometers per second, burning hotter than nearly every other star in the known universe, and racing toward a cataclysmic explosion that will outshine entire star systems for weeks. This is a Wolf-Rayet star, a rare and extraordinary class of stellar giants that exists on the very edge of annihilation. These are not ordinary stars. They are cosmic anomalies living on borrowed time, and their short, turbulent lives hold some of the most important secrets about how stars evolve, how galaxies are enriched with heavy elements, and how the building blocks of life are scattered across the cosmos. To understand Wolf-Rayet stars is to understand the extreme limits of stellar existence, the raw power of nuclear fusion, and the beautiful, destructive cycle that keeps our universe alive and evolving. The story of Wolf-Rayet stars begins with a discovery that stunned astronomers in the 19th century. In 1867, two French astronomers, Charles Wolf and Georges Rayet, were working at the Paris Observatory, studying the spectra of stars in the Milky Way. At the time, astronomers used spectroscopy to analyze the light from stars, which revealed clues about their temperature, composition, and motion. Most stars showed dark absorption lines in their spectra, corresponding to elements like hydrogen and helium, absorbing specific wavelengths of light. But Wolf and Rayet noticed something completely unprecedented. A small number of stars displayed bright, broad emission lines that had never been seen before. These lines were dominated by ionized helium, highly ionized nitrogen, carbon, and oxygen, with almost no sign of hydrogen at all. This was unheard of. Every star known to astronomers was rich in hydrogen, the most abundant element in the universe. These strange stars defied all existing models of stellar structure. They were named Wolf-Rayet stars in honor of their discoverers, and for decades, they remained one of the most baffling mysteries in astronomy. For nearly a century, scientists could not explain why these stars lacked hydrogen, why they burned so fiercely, or why their spectra looked so different from every other star in the sky. It was not until the mid-20th century, when our understanding of stellar evolution and nuclear fusion advanced dramatically, that we began to unlock the true nature of these cosmic titans. To become a Wolf-Rayet star, a star must start its life with an extraordinary amount of mass, at least 25 times the mass of our Sun, and often up to 100 times solar mass. These are not the small stable stars that fill most of the galaxy. They are the true heavyweights of the stellar world, born from the densest, most massive molecular clouds in space. In their youth, these stars are classified as O-type stars, the hottest, brightest, and most short-lived stars on the main sequence. They burn through their core hydrogen fuel at an astonishing rate, not over 10 billion years, like our Sun, but over just a few million years. This rapid fusion generates extreme internal pressure and temperature, creating powerful stellar winds that start to strip away the star's outer layers long before its core fuel is exhausted. As the star ages and depletes its core hydrogen, it evolves into a luminous blue variable, an unstable phase marked by unpredictable eruptions and massive mass ejections. During this phase, the star loses huge portions of its hydrogen-rich envelope, exposing the deeper layers, where nuclear fusion has already created heavier elements. Once the outer hydrogen shell is completely gone, the star enters its final evolutionary stage. It becomes a Wolf-Rayet star. This transition is one of the most dramatic transformations in the universe, turning a massive young star into a dense, hot, hydrogen-depleted core that burns with an intensity almost beyond comprehension. Wolf-Rayet stars are defined by a set of extreme physical properties that make them unique among all stellar objects. First, their surface temperatures are mind-blowing, ranging from 20,000 Kelvin to more than 200,000 Kelvin, making them hotter than 99% of all stars in the universe. To put this in perspective, the surface of our Sun is about 5,500 Kelvin. A Wolf-Rayet star can be more than 35 times hotter. This extreme heat gives them a brilliant blue-white glow that cuts through interstellar dust and gas, making them visible even in distant galaxies. Second, they possess the most powerful stellar winds in the universe. These winds blast outward at speeds between 1,000 and 2,000 kilometers per second, fast enough to travel from Earth to the Moon in just over 2 minutes. The mass loss rate is equally staggering. While our Sun loses about 1/10 trillionth of its mass every year, a typical Wolf-Rayet star loses 1/10,000th of a solar mass each year. Over its short lifetime, A Wolf-Rayet star can shed 10 to 30 times the mass of our Sun, enough to form entire planetary systems. This constant, violent ejection of material creates vast glowing nebulae around the star, formed by the collision of the fast stellar wind with slower, earlier ejections. One famous example is RAR 124, captured in stunning detail by the James Webb Space Telescope, surrounded by the glowing, clumpy nebula M1 to 67A, cosmic tombstone, being carved by the star's own death throes. Astronomers classify Wolf-Rayet stars into 3 distinct subtypes based on their surface composition and spectral features, each marking a different stage in their final evolution. The first type is WN stars, dominated by ionized helium and nitrogen. These stars are the least evolved Wolf-Rayets, still showing the byproducts of hydrogen fusion via the CNO cycle. Their surfaces have lost most hydrogen but retain strong nitrogen signatures. The second type is WC stars, which show strong emission lines of carbon and oxygen with almost no nitrogen. These stars are more evolved, having burned through helium in their cores via the triple alpha process, creating carbon and oxygen that rise to the surface. The rarest and most evolved type is WO stars, which feature highly ionized oxygen lines and represent the very final stages before core collapse. Each subtype tells a story of the star's internal fusion processes, revealing how deeply it has burned through its nuclear fuel and how close it is to total destruction. This classification system allows astronomers to map the life cycles of these stars and understand the physical processes driving their rapid evolution. What makes Wolf-Rayet stars truly extraordinary is not just how they live, but how they die. Their lives are extraordinarily short, lasting just a few 100,000 to a few million years, a blink of an eye in cosmic time. For comparison, our Sun will live for 10 billion years. A Wolf-Rayet star entire lifetime is shorter than the time dinosaurs roamed the Earth. This brevity is because they burn fuel at an unsustainable rate, and once their core can no longer generate enough energy to counteract the crushing force of gravity, collapse is inevitable. When a Wolf-Rayet star dies, it does not go gently. Its core collapses inward in a fraction of a second, triggering a core collapse supernova of type IB or IC supernovae that lack hydrogen lines, exactly matching the composition of Wolf-Rayet stars. These explosions are among the brightest events in the universe, releasing more energy in a few weeks than our Sun will produce in its entire lifetime. The blast wave travels outward at millions of kilometers per hour, sweeping up interstellar gas and triggering the birth of new stars in its wake. But the destruction does not always end there. Under the right conditions, especially if the star is rapidly rotating and has low metallicity, the core collapse can produce a gamma-ray burst, the most energetic explosion in the known universe. These bursts release focused jets of gamma radiation that can be detected billions of light years away, and they are thought to be directly linked to the deaths of massive Wolf-Rayet stars. After the explosion, the core of the star is compressed into either a neutron star, an ultra-dense object the size of a city with the mass of a star, or a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. In death, Wolf-Rayet stars give birth to some of the most extreme objects in the cosmos. Beyond their spectacular deaths, Wolf-Rayet stars play an irreplaceable role in shaping the chemical evolution of galaxies and the universe as a whole. Before stars like these existed, the universe was composed almost entirely of hydrogen and helium, created in the Big Bang. All heavier elements, carbon, oxygen, nitrogen, iron, and the elements that form planets, rocks, and even living organisms, were forged in the cores of massive stars and scattered into space when those stars died. Wolf-Rayet stars are among the most prolific producers of heavy elements. Their powerful stellar winds eject vast amounts of carbon, oxygen, and nitrogen into the interstellar medium, enriching gas clouds that will later collapse to form new stars and planetary systems. Every breath we take, every carbon atom in our bodies, every oxygen molecule that sustains life, can be traced back to the nuclear furnaces of massive stars like Wolf-Rayet stars. They are the cosmic recyclers, turning stellar ash into the building blocks of planets and life. Without these doomed giants, the universe would be a barren place, devoid of the complex elements needed for life as we know it. They are destroyers and creators in one, a perfect symbol of the cosmic cycle of death and rebirth. Observing Wolf-Rayet stars has always been a challenge for astronomers due to their rarity, their distance, and the dense dust clouds that often surround them. It is estimated that only about 500 to 600 Wolf-Rayet stars have been catalogued in the entire Milky Way galaxy, a tiny number compared to the hundreds of billions of stars that exist. For decades, ground-based telescopes struggled to resolve these stars and study their properties in detail. But in recent years, modern space telescopes have revolutionized our understanding. The Hubble Space Telescope has captured stunning images of Wolf-Rayet stars and their surrounding nebulae, revealing the structure of their stellar winds and the dynamics of mass loss. The James Webb Space Telescope, with its infrared vision, can pierce through the dust that shrouds many Wolf-Rayet stars, allowing us to study their surfaces, their winds, and their nucleosynthesis in unprecedented detail. These observations have confirmed decades of theoretical models and revealed new surprises, such as the complex structure of nebulae formed by colliding stellar winds, and the role of binary star systems in shaping the evolution of Wolf-Rayet stars. Many Wolf-Rayet stars exist in binary pairs, where gravitational interactions with a companion star accelerate mass loss and speed up the star's evolution, creating even more extreme conditions. Even with all we have learned, Wolf-Rayet stars still hold many mysteries that continue to challenge astronomers. We do not fully understand the exact mechanisms that drive their extreme stellar winds, or why some massive stars become Wolf-Rayet stars, while others follow different evolutionary paths. We are still learning how binary interactions affect their development, and how their explosions influence the formation of black holes and gamma-ray bursts. Every new observation brings us closer to answering these questions, but each answer also reveals new layers of complexity. These stars remind us that the universe is far more wild, extreme, and wonderful than we can ever imagine, and that there is always more to discover beyond the edge of our current knowledge. When you look up at the night sky, you are seeing stars that live quiet, stable lives, burning steadily for billions of years. But somewhere in that darkness, hidden among the familiar constellations, are the Wolf-Rayet stars, the doomed giants burning bright, tearing themselves apart, and preparing to explode in a fireball that will echo across the galaxy. They are a testament to the power, the beauty, and the fragility of stellar life. They teach us that destruction is not an end, but a beginning, that from the death of the most massive stars comes the material for new stars, new planets, and new life. They are a reminder that the universe is not static, but a dynamic, ever-changing tapestry of creation and annihilation, written in the light of stars that live fast and die bright. Wolf-Rayet stars are more than just astronomical objects. They are storytellers, recounting the epic tale of cosmic evolution, from the Big Bang to the present day and beyond. As we continue to study these extraordinary stars, we do not just learn about the universe, we learn about our place within it, connected to every atom forged in the heart of a dying giant. Please like, comment, share, and subscribe to the channel